Now let us discuss the code for vm.cpp. Now as we have seen that it requires two header files, page.h and process.h. So let us discuss first these header files. Now in the page.h file we have included the libraries which we may require. Now here we have declared a class named page. So in this class we have some variables like a array of characters named alpha, in which we have stored all the characters, so that it is required so that we can give each page a unique page name for each page in our memory. Then we have a stream ss, which we'll see further why it is used, and then a PID, that is process ID, means this page is associated with which process. We have to store that, so integer called PID is declared. Then we have page ID. Now this is a unique page ID which will be associated with each page in the page table. Then we have a page name, the unique page name for each page in the memory, and then we have a valid bit for that page. Now valid bit means if it is set to 0 means that page is not in the main memory, and if it is 1 then it is in the memory. So now we are having a method called page. We are passing some arguments to this method, that is integer PID, page ID and valid bit. We will assign these arguments to here on line 27. We are assigning the passed arguments to our this PID integers. Now we are this method we will call objects of this method class in our code, so to create different pages. So now we are assigning your PID, page ID, which is again a argument, and then we are adding that page ID to the string stream here, which we have declared previously. So the string stream we are ss, we are giving the page ID, and then the page name for that string. We are using a method for naming that page, means we are first from this array we are assigning the that number of variable letter to the page name, means if it is 3 then on the third place we have d, then d plus ss dot string, means it was page id was 3 4 for example, then d4, this is the unique page name for that page. And then we are assigning the valid bit, means whether this page is in the main memory or not. So this was all about the page, means for creating pages for each process we will call this function, this class. Then next we have the process. Now this process header file contains the class for each process. Now in this plist.txt we saw we want 5 processes. So to make these 5 processes in our system we are going to call this class. Now what all information this class contains? It contains a process ID for each process, then the size of memory which will be required for that process, then num pages, it is the number of pages which will be required by that process, and then we are declaring a page table which is a vector of type page, means it will be a vector where a group of pages will be stored, and it for each process we will have a page table. Then again a method with arguments PID, size and the size of pages. Now here in this program we have given a hard-coded size of pages, means 5 is the size of page. One page can contain 5 is the size. Then we are assigning the PID is the process ID, then the size for that process. Here now for 0 process we have 500 size, so that size will be assigned to size. Then num pages. Now num pages means how many pages will be required to store this process information, means this process memory. So the size is 500 and the size of pages which we have taken is 5, means one page can contain 5 memory locations. Then the number of pages required will be 500 divided by 5, which is equal to 100. Now means the number of pages for storing process 0 will be 100. And then now for example, this if is condition is for the numbers like if there is some extra memory remaining. Now for example, if the size is here, if the size is 502, then 502 divided by 5, it will be 100 only, but the rest two memory locations are remaining. So we will check whether the modulus is greater than 0. Now if our page size is 5, then it will be, the modulus will be between 1 to 4. So we are checking if it is greater than 0, then we will increase one page. Now 502 modulus 5 will be 2, so it is greater than, so we are increasing one page. Now it will be 101 pages. Now we know the number of page count for this specific process. Now for that we have to create that many pages. So by using a for loop, we are making objects of the page class. Here on line 30 we are making the object new page, passing the process ID of this process, then I is the page number. See, I is the page ID. Now here we are assigning the page ID as I, and then 0 is the valid bit, means for now the page is not in the main memory, it is in our virtual memory. And then we are passing these pages which we are going to create to our page table vector, which is a vector of pages. So with the help of for loop we will create the number of pages required for each process. Now for example, here 250, the for process 1 we require 250 memory size is 250. So 250 divided by 5, we have 50 pages. So for process 1 we will require 50 num pages. This was all about our header files. Now let us see how we are going to use these header files in our program.